All right, let's talk about one of the biggest, most fascinating questions in AI right now. What is the real difference between an AI that just sounds smart and one that actually is smart? We're going to look past the smoke and mirrors of statistical mimicry and explore the incredible future of true artificial reasoning.
I mean, we've all seen it, right? You ask an LLM to write a poem, debug some code, or explain a super complex topic, and it just does it. It feels so much like real intelligence. But is it? Or is it just an incredibly sophisticated parrot, a master of patterns? Can it truly reason, or is it just predicting the next most likely word? That's the puzzle we're digging into today.
So, before we get into the weeds, let's just start by appreciating the absolute magic of what these systems can already do. Honestly, the capabilities are mind blowing, and they're the whole reason we're even having this conversation. At its heart, AI reasoning is all about building systems that don't just spit back information, but can actually draw conclusions. The goal is to process a bunch of data, find the hidden patterns, and then make a logical leap to solve a problem. It's about moving from just knowing facts to actually using them. And what you're seeing here is just how versatile LLMs have become. It's pretty wild. They could do logical deduction, sure, but also common sense stuff, math problems, and even causal reasoning, figuring out cause and effect. And then there's abductive reasoning, which is basically making an educated guess or forming a hypothesis. And it learns all of this just by finding statistical patterns in mountains of text. Incredible. But, and this is a really big but, this is where we hit a snag. For all of its power, this amazing ability has a bit of a crack in its foundation. We're about to peel back the curtain and look at what some call the illusion of understanding. Okay, this is absolutely crucial to get. An LLM is a semantic engine. It's a master of relationships between words. It knows puppy is to dog what kitten is to cat. But a logic engine, it doesn't care about relationships. It cares about absolute verifiable rules. It knows that if statement A is true and statement B is true, then A and B must be true. No exceptions. One plays the game of probability, the other plays the game of proof. And this brings us to what researchers call the category error. This is the big mistake we all make. We see an AI produce text that looks perfectly logical, and we just assume it actually thought its way there using logic. But it didn't. We're confusing the way logic sounds with the process of actually doing logic. So to put a finer point on it, a category error is like asking, what's the smell of the color blue? It's a nonsensical question because you're applying a property to something that can't have it. And when we talk about an LLM understanding things, we're doing the same thing. We're mistaking a system that's brilliant at predicting the next word for a system that actually comprehends truth and falsehood. So this brings us right to the heart of the matter, the massive difference between simply mimicking reason and performing true, structured inference. Let's break down what that really means. This visual just nails the difference. On the left, you've got statistical mimicry. It's kind of like a jumbled pile of blocks that looks plausible from a distance. It's built on probability, what's most likely to come next. But on the right, you have structural inference. It's an orderly, solid structure built on verifiable rules. It's based on proof, not just what sounds good. And this is why that mimicry is so fragile. If you throw it a curveball, something it's never seen in its training data, it just falls apart. It has no pattern to copy. And it constantly falls for the correlation fallacy, thinking that just because two things get mentioned together a lot, one must cause the other. For anything important, that's just not reliable enough. Okay, so that's the problem, and it's a big one. But this is where it gets really exciting, because the solution is already being built. Researchers are now focused on creating a totally new kind of AI. You can think of it as a hybrid mind. They're called hybrid reasoning architectures. It's a fancy name, but the idea is actually super intuitive. You don't get rid of the amazing creativity and language skills of an LLM. Instead, you anchor it. You connect its probabilistic, creative guesses to a rock-solid, rule-based system that can check its work. You get the best of both worlds. So how do you do it? Well, the first approach is to teach the LLM to know its own limits. You train the model to recognize when it's facing a problem that requires perfect precision, like complex math or formal logic. And instead of trying to guess, it learns to delegate. It just hands the problem off to a specialized tool, like a calculator, that guarantees the right answer. Another really clever solution is to build a sort of AI team. You have one AI agent generate a response or a line of reasoning. But before that answer gets to you, a second critic AI swoops in and checks it against a strict set of logical rules. It's like having a built-in, ruthless fact-checker that catches mistakes before they ever see the light of day. And a third really powerful technique is called grounding. Basically, you force the LLM to check its facts against a reliable, structured database, a knowledge graph, before it's allowed to generate a response. This tethers the AI to reality. It's the key to preventing it from just making stuff up or hallucinating, because its claims have to be tied to a verifiable source of truth.
So when you start putting all these solutions together, the delegating, the built-in critic, the grounding in facts, you can see a clear path forward. We're moving away from these standalone, sometimes unreliable models and towards something much, much more powerful, a truly grounded cognitive AI.
And this quote from the research really just says it all, doesn't it? The future isn't about just building bigger and bigger LLMs and crossing our fingers. Nope. The real breakthrough is creating these smart, hybrid systems that combine the strengths of different AI approaches into something new.
And this right here, this is the end goal. We're trying to evolve from AI that just produces likely sounding text to an AI that performs verifiable causal inference. This is how we build AI we can actually trust with the important stuff, medicine, science, engineering, because its reasoning is grounded in structured, provable logic. And that really leaves us with a final massive question to think about. Once we have AI that doesn't just give us an answer, but can actually prove to us that its answer is correct, what are we going to ask it to solve next? What new frontiers will that kind of trustworthy intelligence open up? The possibilities are just staggering.